Hello, Accelerated Math 7-8 students. We are working in Module 12, and this is Lesson 7, Angles Associated with Parallel Lines. Is the name of our lesson today. And here it is, Angles Associated with Parallel Lines. Our goal for today. Today we will learn about angles that sit on parallel lines. The question that I want you to be thinking about is, how can you determine if one angle is congruent to another? We're remembering that congruent means that they are the same size, same shape, they're equal. Okay, so it's just a fancy name for describing equal. Things to remember, these are types of angles and vocabulary that you already learned. That's why it's under the things to remember. Vertical angles are angles that sit across from each other. The way to remember it is if you have two lines that intersect each other, then we know that the vertical angles would sit across from each other. So this is a vertical angle to this. Okay. Another one would be this is a vertical angle to this. And when they're vertical to each other like that, that means that they're the same size. Okay. So the angle measure is exactly the same. All right. Obtuse angles are angles that measure greater than 90 degrees. Acute angles are angles that measure less than 90 degrees. Things to know. This is new information that you haven't learned yet, and so I'm going to teach it to you right now. Corresponding angles. So the only time that you can use corresponding angles, alternate interior angles, and alternate exterior angles is when you have parallel lines. And the parallel lines have to be cut by a transversal. And so this right here is what we call a transversal. Okay, and we'll get there. But there has to be a transversal line present, or you cannot have any of these angles. Okay, so corresponding angles are angles that are the exact same angle measure, but are in different locations. And so what you need to think about is the transversal that intersects the parallel lines creates these positions that we're talking about. So the angles that correspond, according to this one, is angle 1 corresponds with angle 5. And what that's telling you is that the angle measure of number 1 and number 5 is exactly the same, but they're in different locations. So if it's on the top left of the transversal, then the angle that sits at the top left of the transversal in the parallel lines, they're exactly the same. So these are corresponding. So 3 and 7 would be corresponding because they're the exact same size. Okay. 8 and 4 would be corresponding. Okay. And the other one that we have is 2 and 6 are corresponding. We can add that to our list. All right. 2 and 6. So let me put that on there as one more thing. So angles 2 and 6 can also go on that list. All right, so those are all corresponding, okay? Alternate interior angles are angles that have the exact same angle measure but sit opposite each other across the transversal inside the parallel lines. So you have to take the two lines that are parallel and only focus on the angles that are in here. So an alternate interior angle would mean the angles inside and the ones that sit across from each other. So what you can say is that angle measure 3 is the same as angle measure 6 because they're alternate interior. So that means this angle measures exactly the same degrees as this angle measures right here. You can say that angle 4 measures the exact same number of degrees as angle 5. Okay, and that is proven by alternate interior angles. Okay, the last one that I'm going to share with you is alternate exterior angles, and those are angles that have the exact same angle measure but sit opposite of each other across the transversal outside the parallel lines. So exterior means outside the parallel lines, interior means inside the parallel lines. So when you're looking for exterior, you're focusing on the angles on the top and on the bottom, and that's it. And so we would say that angle 2, measures exactly the same size as angle 7, and we would say angle 8 has the exact same angle measures as 1. So 1, 4, 5, and 8 are exactly the same size. 2, 3, 6, and 7 are exactly the same size. We know 2 and 3 are the same because of the vertical angle rules. We know that 3 and 6 are the same because of alternate interior, and we know that 6 and 7 are the same because of vertical angles. We know that 7 and 2 are the same because of alternate exterior. So you should be able to see a pattern looking at this, okay? And so pay very close attention to those because they're really helpful in helping you figure out what is going on, all right? The transversal, I noticed that I forgot to write a definition, so you're going to help me with that definition right now. The transversal is a line that intersects a pair of parallel lines and creates angles. Okay? Because you'll notice if this line right here, this transversal, it has a T to mark that as a transversal. If it wasn't here, there'd be no angles. But the minute that transversal intersects with the parallel lines, you see 8 different angles being created. Okay? And you've now learned about the angle measures because of the transversal. So all of these angles in the things to know section would not exist without a transversal. So the transversal is pretty powerful. A line that intersects a pair of parallel lines and creates angles. Then you get to use these rules to determine the size of those angles, and it becomes very helpful, and you'll see that in our practice in class. So our goal today we will learn about angles that sit on parallel lines. We did that, and those angles only can be there because of the transversal. How can you determine if an angle is congruent? Well, the answer to that is remember these rules, because these rules help you identify what type of angle it is, and then you know that they are the same because of those rules. Okay? We're going to practice a lot of these in class, and it's a pretty fun thing once you can get it figured out. That's all I've got for you. See you later. Bye.